Dear students, this is a continuation of the previous video. Okay. Now you see the third question. F of z is equal to 1 over z minus 1 multiply z minus 2. The given region is mod z greater than 2. Okay. Now you see the function. This is also a same function. Now what we do partial fractions to write as 1 over z minus 2 minus 1 over z minus 1. Okay. Now you see here the given region is modulus of z is greater than 2, which means what? Now you see this is modulus of z is equal to 2. Okay, but we need the region is modulus of z is greater than 2, which means here you see the squares. Okay, so outside this circle. Okay, even this boundary line is not included, outside the circle only. Okay, that is modulus of z is greater than 2. Okay, now here you see as usual. So what is here? The pole 1 and 2. So I write the poles 1 and 2. Okay, now you see after writing the given function by using the partial fraction like 1 over z minus 2 minus 1 over z minus 1. Now you see in the first term you take z as a common factor, and the even second term also you take z as a common factor. Okay, so here if you take z out, what will happen? 1 over 1 minus 2 over z minus, if you take z outside in this term, so 1 minus 1 over z. Okay, now you see why we take z outside. Then after taking that, here what you have, you see here what you have, here what you have, how we fix this condition, the given region for this. Okay, now you see modulus of z is greater than 2 is given, which implies, now you see you cross multiply z, so 2 over z, modulus of 2 over z is less than 1. From this expression I can get, so here what I'm getting, modulus of 2 over z is less than 1. Okay, so that here what I required, 1 minus this value should be less than 1. So this is correct. Okay, I can write this term in summation form. Okay, for here 1 minus 1 over z. Okay, now this is the given region in the question. Now from this you see here what is here, modulus of z is greater than 2, which implies definitely modulus of z is greater than 1. Okay, which implies, now you see cross multiply this z, so what will happen, modulus of 1 over z is less than 1. Okay, so now here what we require, 1 over z should be less than 1, means modulus of 1 over z should be less than 1. Okay, so that's also here we have means rewritten from the given condition. Okay, so now in the second term also this is satisfied, so that I can write in the summation form. Okay, so now 1 over 1 minus x. Okay, so that I can write sigma n equals 0 to infinity 2 over z, because this is our x, so this is our x, so x power n, like that. Similarly minus this sigma n is equal to 0 to infinity, this is our x, so x power n, that is 1 over z power n. Okay, now here you multiply this 1 over z here and here. Okay, so that here 2 power n divided by z power n plus 1, here 1 over z power n plus 1. Okay, after that you take 1 over z power n plus 1 as a common factor, so that this is the remaining value. Okay, so now what is this, sigma n equal to 1 to infinity 2 power n minus 1 minus 1, 1 over z power n is nothing but the Lorentz series of the given function in the region mod z greater than 2. Okay, so this is the region mod z greater than 2. Okay, all squares. Okay, now that's it. Now you see another question, question number 4. Now find a Lorentz series expansion for f of z is equal to 1 over z minus 2 z minus 1, same function, but you see here the condition, the region 0 less than mod z minus 1 less than 1, which means what, see, which means what, see in the picture the region is the punctured disk, which means the interior without the center. You see here this is not included, means center is not included, because 0 less than mod z minus 1 less than 1, which means see this center, this point is not included, but except at this point all included inside this circle. Okay, that's why they are writing the region is the punctured disk. Okay, the interior without the center. Okay, so now here valid for the this function valid for the indicator annular domain. Okay, this one. Okay, now modulus of z minus 1 less than 1 implies powers of z minus 1. Here no need to write this function into the partial fraction to decompose. Okay, now here we just factor out the term with the isolated singularity, that is the same as the center, and deal with the other term, which means now you see here 0 less than mod z minus 1 less than 1, which means here this is here from the in the function, no, don't touch this z minus 1 term. Okay, because we are going to write the series of this function in terms of z minus 1 only. Okay, so don't touch this. Okay, except this, what you have 1 over z minus 2. Okay, so now how to rewrite this 1 over z minus 2 to write in summation form, that we will see. See, we see here what is mentioned here. Okay, now z equal to 2 is one pole, z equal to 1 is another pole. So now that is mentioned here. But here this 1, the pole z equal to 1 is coincide with the center. Okay, so that's why here written. See, there is no need to partial fraction decompose, since the center in one of our isolated singularities. Since the center in one of our isolated singularities, the center is this, but it is coincide with the one isolated singularity. Okay, that is z equal to 1. Okay, what is isolated singularity we will see later. Okay, what we do here, f of z is equal to 1 over z minus 1 multiply 1 over z minus 2. Don't touch this. Now we rewrite this. How we rewrite this? 1 over 1 minus of z minus 1. Okay, so now what is this? See, this is nothing but 1 over 1 minus x form. Again, rule 2 we can apply here. That's it. Now that's why 1 over z minus 2 is equal to nothing but this 1 over minus 1 plus z minus 1. See here what we are doing here also. Now we take 1 over minus 1 plus of z minus 1, and then we take 1 minus outside, so that we will get this. See, now this is 1 minus x. By rule 2 I can write this summation form for this one. Okay, see here minus is in front of the summation. Okay, so now this is for mod z minus 1 less than 1, because you see here I apply the rule here, so that I have to check this is less than 1. Yes, this is less than 1, just given. Okay, less than 1, so that we write like this. Okay, so modulus of z minus 1 is less than 1. Okay, now here what is f of z? F of z is this. Okay, so 1 over z minus 1 already we have. For 1 over z minus 2 only we are writing this summation. So now what we do here, for 1 over z minus 2 we replace this. Okay, so this is equal to 1 over z minus 1, we write this here. Okay, and then we can multiply z minus 1 inside the summation, so that minus sigma n equals to infinity z minus 1 whole power n minus 1. Okay, so this is the Lorentz series of the given function in the region 0 less than mod z minus 1 less than 1. Okay, that's it. Now you see another question. Again, same function, we have to write the Lorentz series, but the region is 0 less than mod z minus 2 less than 1, which means what? Now here what is the center? Center is 2, 0, this one, center. What is the radius here? 1. So from here 1 unit radius, so we make this circle. So now this is square. See the region which is inside this circle, not boundary included, and it is also punctured disk. See, this is not included, the center is not included, because the center is coincide with one of our, see this one of our singularity. Okay, now you see z minus 2 less than 1. Okay, so what we do, just you do alternate, not alternate. See here what, see here 0 less than mod z minus 1 less than 1 is given, so that what I do here, z minus 1 I keep as it is, z minus 2 I 1 by z minus 2 I wrote in the summation form. Same here, see z minus 2 modulus of z minus 2 less than 1 is given, so what I do here, 1 over z minus 2 I keep as it is, then 1 over z minus 1 I write in the summation form. Okay, so see here, same approach, same arguments. Now so I rewrite 1 over z minus 1 like 1 minus of z minus 2. After that, what I do here, so 1 over z minus 1 is nothing but I can write like this. So now 1 over 1 plus z minus 2. So now here you take minus as common. So this is nothing but I can write the rule 2. So that sigma n equals 0 to infinity minus 1 power n z minus 2 whole power n. Okay. So that now, so this is the value of, this is the summation of 1 over z minus 1. So what is the given function? Given function is 1 over z minus 2 multiply z minus 1. So 1 over z minus 2 multiply z minus 1 in the denominator. So that now see 1 over z minus 2. For this I have this answer. So write it here. So next what we do, you multiply z minus 2 in the denominator. We have z minus 2, multiply here. So that what will happen, so here z minus 2 will be in the denominator, so you combine in the numerator. That's why z minus 2 whole power n minus 1. Okay, so this is your Lorentz series of the given function, the region 0 less than mod z minus 2 less than 1. Yes, because see, when you write the summation form of this, see, you have to check this value is less than 1. Yes, less than 1. That is here. Okay, given in the region. Okay, so that we have completed the Lorentz series of the function. Okay, now you see here what are zeros and poles. Okay, you see this is the definition for zeros and poles, and now we will see the example for this. See, this is the given function z plus 1 by z cube multiply z square plus 1. Actually already we have seen this. Okay, now see, 0 is nothing but you find the value of z in the numerator of the function, in the function, then you write that is z equal to, see here, z equal to minus 1 is a 0 of order 1. Okay, you see in the denominator you find the values of z, you write that value is pole. Okay, and then you see the degrees of each term. Okay, each factor. So now here degree is 3, so pole of order 3. So 0 is a pole, z is equal to 0 is a pole of order 3, z equal to I is a pole of order 1, z equal to minus I is a pole of order 1. So here z equal to 0 is a pole of order 3, like that you can write. 0 is nothing but you see the numerator here, what is the value of z, and you see the degree. Okay, here degree is 1, z equal to minus 1. So 0 z equal to minus 1 is a 0 of order 1. Okay, see, in other words we can say the pole is nothing but the singular point. Okay, singular point, singularity. Okay, now that's what we discussed in the question also here. Okay, in the question we discussed isolated singularities. Okay, now we have isolated singularity. What is isolated singularity? Now you see the function z plus 1 divided by z cube multiply z square plus 1. See the same example, this one. But here what we are writing as the three isolated singular point, z equal to 0 and z equal to plus or minus I. Now you see the pole is nothing but, see here I am writing z equal to 0 is a pole, z equal to I is a pole, z equal to minus I is a pole, is nothing but is a isolated singular point. We can say that the pole is nothing but we can call by another name isolated singular point, that is z equal to 0, z equal to I, z equal to minus I. Okay, so now here what is isolated singularity, that is the definition is given here. Okay, see this is also example, this is also isolated singularity example. Now you see here what is there, z is 0, this z is equal to 0 is isolated singularity for this function, for this function, for this function, for this function. Okay, now you see here your function is like this. I can go here in the denominator, I can write the isolated singular points, but your function is like this. Then how to find, we will see in the examples. Okay, that's it. Thank you. We will see the continuation of this lecture in the next video. Thank you.